as promised, we're playing around with number theory stuff today, so we're going to look at primes and composites. Has anyone ever heard of the sieve of Eratosthenes? Cool, you've heard of it. Today we're going to see a sort of an interactive demonstration with how it works. So on the brick wall, this awesome brick wall in the back, there's a number line that goes from 1 to 100. And we're going to do an interactive demonstration with how this sieve works to uncover all the primes between 1 and 100. At the very beginning of that list is 1. Give me a thumb up or a thumb down if your answer is yes or no. Is 1 a prime number? You can hold it close to your chest. You don't have to advertise, yes, it's a prime number, no, it's not a prime number. And if you're really not sure, you could go somewhere in the middle. All right. Can I ask a thumb downer to tell us why you believe that 1's not a prime number? I'm willing to make an argument?
Yeah, tell me your name.
Every division, Ahmad.
Ahmad.
Prime number is divisible by 2 numbers and only 2 numbers.
A prime number must be divisible by 2 and only 2 numbers. And the problem with 1 is that it's
By itself, just only 1.
divisible by 1 number.
Is it
itself.
different numbers? Would you say 2 different
Different.
numbers?
1 and itself.
No, I get it, but would you define, can I ask this question?
Absolutely.
So my kids argue, yeah, but it's 1 times 1. So those are 2 numbers.
Different.
Okay, so then I had to inject different numbers.
So that's an interesting, my students are often unsatisfied with that explanation also. But what about 1 times 1? So then how might you counter the what about 1 times 1 question if a know-it-all 7th grader comes back at you with that question?
It's the same factor.
It's the same factor?
It's the same factor.
Sure.
I need 2 separate factors.
Yeah. Because we're trying to make the argument that 1 has only 1 factor, and they're trying to tell you that it has 2, right? Are there any other numbers that have like an odd number of factors?
Well, I was just thinking about this before you said with squares, like you don't have a 36. You're not you've got 6 and then 6 and then 9, right? You just list 6 once.
Right. Like if you're gonna list all the factors, I'm gonna pick 4 because there's less factors.
Sorry, that was just what popped into
Totally.
my head.
But if I asked you to make a list, in ascending order of the factors of 4, you'd say 1, 2, 4.
Right.
Right? 1 and 4 pair up. 2 pairs up with itself, but I don't know. That might help you win. But anyway.
Primes is one of those things that's like, students often ask me, was math discovered or invented? Primes are the kinds of thing that it was invented, like that definition was decided. And actually for a long time, 1 was believed to be prime. It later was decided that it can't be prime because it messes up the fundamental theorem of arithmetic.
Yes.
I was just going to say, be careful, I think, with language if you use, like, itself, because that's how 1 in itself, itself, well, 1 is itself, so that's why I think you have to be careful, like, the 2 different, if you use itself, that's where I think it can be confusing for some of the kids.
Because 1 is itself.
Right.
Attend to precision in your definition
Right.
of numbers.
Yeah.
Very good.
I play that Three Dog Night song, What is the Loneliest Number? And we sing it so that they'll remember.
Nice. Is that why? It's because it's neither prime nor
There you go.
composite? So it's just all by itself? Alright. Yeah. Should I expand on why 1 had to become not prime due to the fundamental theorem of arithmetic?
Please.
Do you guys know what the theorem says? Anyone know that theorem?
Doesn't need to be fancy math language. We can use everyday language. It says that any positive integer has a unique factorization of primes. We don't usually throw 1 in the mix, right? The prime factorization of 8 is 2 times 2 times 2. We wouldn't usually say it's 2 times 2 times 1, especially once you do that, then you can create non-unique factorizations of primes if 1 is prime, right? You could do 2 times 2 times 1. No, 2 times 2 times 2 times 1. You could do 2 times 2 times 2 times 1 times 1. So you keep going. You see where that goes? Like all of a sudden you have several factorizations of primes that are not unique, and so it messes up that theorem. So 1 can't be prime for that reason. And that happened probably in the last few hundred years. And so for hundreds, maybe thousands of years before that, it was assumed to be prime.
Do you have that written down?
Nope.
Actually, the fundamental theorem of arithmetic is in your binder.
Yep.
So we'll come across that.
We'll steer you to that momentarily. So Christina's going to go back to our number line and
To the number one.
X through 1. Yeah, so
Just, this is kind of off topic. There's a really great TED presentation talk about prime numbers
yeah.
that someone does a poem to. He's like the international poetry, blah, blah, blah. So it's kind of long. I'll try and find it. But it's this British guy, and he's like, I'm a mathematician and I'm a poet, and he does this really fast poem about primes, and there's a romance and
Wow.
So
Yeah,
that's
I'll find
a
it.
perfect example of the
Parking
use
lot.
of our Edmodo page. So if you can find that and post the link in Edmodo, then that's a place that we can keep. And then
Kate's
you
doing
guys
some
can
work
grab
on
it
that.
and put it in your Google Sites to remember forever.
We just got recorded, dude.